This is the other type of classic instantaneous center problem. It's a wheel rolling, it might be rolling on the ground and the velocity of the ground is zero. In this case, it's rolling between two belts that are both moving. So it's going to ask what's the omega typically, and what's the velocity of the center? Okay, let's draw what we know. Let me try to draw this circle as carefully as I can. Okay, we know that the bottom point B is touching the ground, and it'll say something like no slipping. So I have the same velocity as the ground at 0.4 meters per second. And similarly, the top at A is 0.25 meters per second. And so we try a little trick and draw perpendicular and perpendicular, and they're aligned. So let me redraw those velocities to scale. So here's 0.25, and down here 0.4. Okay, there they are, drawn to scale. And I draw perpendicular to that one, perpendicular to that one. They align because the two velocities are parallel. So all you got to do is connect the dots like that, and we should be able to figure out these distances. Let's call that D1 and D2, and you can see that the overall distance is 0.25 meters. We know that this is coincidentally also 0.25 meters per second. And this one down here is 0.4 meters per second. And using similar triangles, in particular, you need to see this triangle right here. That triangle has a height of 0.25 meters and a run of 0.65 meters per second. And so I'm just going to use similar triangles. D1 equals 0.25 over 0.65. And you can practice this and figure it out. All I did was I drew these two triangles, D1 0.25 and 0.25 and 0.65. Yeah, I just drew those in my head. I've done it so many times. I knew that's what it would be. 0.25, 0.65 times 0.25. And that comes out to 0.0962 meters. And similarly, D2 equals 0.4 over 0.65 times 0.25. And that equals, just a second, 0.1538 meters, and D1 plus D2 had better equal 0.25 meters. And drum roll, yes. Okay, we know those distances, and we know where the instantaneous center is. So 0.0962 meters from the top, or 0.1538 meters from the bottom is the instantaneous center. And so we know that the velocity of B equals R, which is the distance from the instantaneous center to the bottom B was 0.1538 meters. Okay, from the instantaneous center. Let me try to draw it here. That distance is 0.1538 meters times omega equal to velocity, which we know is 0.4 meters per second. So solving for omega, so 0.4 divided by 0.1538 is 2.6 meters, radians per second. Quick double check, omega times d1 should equal 0.25, so 2.6 times 0.0962 is 0.25 meters per second, so it works. Okay, so we got the omega. Next is going to be find the velocity of c, so that's the center. Well, that's not the center. The center is, oops. The center is down here, right in the middle. Okay, so velocity of the center is velocity of b plus velocity, oh, what am I doing? I'm doing this instantaneous center. So the distance from the instantaneous center to the center of the wheel, the instantaneous center is 0.1538 meters above the bottom, sorry. Let me just redraw a picture. Okay. The distance there is 0.125. The instantaneous center was at 0.1528. So the distance from the center to the instantaneous center is 0.1538 minus 0.125 equals 0.0288 meters. If I did that subtraction right, I better not do that in my head. So 0.1538 subtract 0.125. Oh, I got it right. Okay, so that's this distance here. Let me draw in red. Okay, that's the instantaneous center. That's the actual center. And this thing is spinning clockwise. So the velocity of c is a distance from the instantaneous center times omega, 2.6 radians per second, okay, equals 0.0749 meters per second, and it's going that way because c is below O and it's spinning clockwise.